Hello everyone. A scalar product of the force acting on an object and the displacement caused by that force happens in the case of a constant force. This is all related to work. So today let us learn something more related to that in a lesson work and energy. Work. Work is said to be done when a force acts on an object and the object is displaced in the direction of force. The work done on an object is the product of the force applied and the displacement. Work done is equal to force multiplied by displacement. That is W is equal to F multiplied by S. The unit of work is joule. If F is 1 Newton and the displacement is 1 meter, then the work done is 1 Newton meter or 1 joule. So 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Example, if a force of 5 Newton acts on an object is displaced through 2 meter in the direction of force, then the work done is 5 Newton multiplied by 2 meter is equal to 10 Newton meter or 10 joule. The work done by a force may be positive or negative. The work done by a force is positive if the force and displacement are in the same direction. The work done by a force is negative if the force and displacement are in opposite directions. The work done by a force is zero if there is no displacement. The work done by a force is zero if the force is perpendicular to the displacement. Example, when we lift an object, the object moves upward in the direction of force. Here the work done is positive, but there is the force of gravity acting downward on the object. The work done by the force of gravity is negative. Another example, a potter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. Mass of the luggage m is equal to 15 kg. Displacement is equal to 1.5 meter. Acceleration due to gravity is equal to 10 meter per second square. Work done W is equal to F multiplied by S is equal to mg multiplied by S is equal to 15 kg multiplied by 10 meter per second multiplied by 1.5 meter is equal to 225 kg meter per second square is equal to 225 Newton meter, which is equal to 225 joule. Energy. The energy of an object is its capacity for doing work. The unit of energy is the same as that of work, that is joule. 1 joule is the energy required to do 1 joule of work. 1000 joule is equal to 1 kilojoule. There are different forms of energy. They are heat energy, light energy, electrical energy, chemical energy, mechanical energy, etc. Kinetic energy. The kinetic energy of an object is the energy possessed by the object due to its motion. All moving objects possess kinetic energy. A falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, a running athlete, etc. possess kinetic energy. The kinetic energy of an object depends upon its speed. An object moving faster has more kinetic energy than an object moving slower. The kinetic energy possessed by an object of mass m and moving with uniform velocity v is kinetic energy is equal to half mv square. Example, an object of mass 15 kg is moving with a uniform velocity of 4 meter per second. What is the kinetic energy possessed by the object? Mass of the object m is equal to 15 kg. Velocity of the object v is equal to 4 meter per second. Kinetic energy, we have the formula. Substituting the values, we get the answer 120 joules. The kinetic energy of the object is 120 joules. Next subtopic is potential energy. The potential energy of an object is the energy possessed by the object due to its position or shape. Example: if a rubber band is stretched and then released, it regains its original position. When the rubber band is stretched, energy is transferred to it and stored as potential energy. Second one, if we wind the key of a toy car and place it on the ground, it moves. When we wind the key of the car, energy is transferred to the spring inside and stored as potential energy. Next, if we lift an object to a height and release it, it falls down. When the object is lifted, energy is transferred to it and stored as potential energy. Our next subtopic is potential energy of an object at a height. When an object is raised to a height, its energy increases because work is done on it against gravity. The energy present in such an object is called gravitational potential energy. If an object of mass m is raised to a height h from the ground, the force required to raise the object is equal to the weight of the object mg. Work done is equal to force multiplied by displacement. We have the following formula. Potential energy gained by the object is potential energy is equal to m multiplied by g multiplied by h. Example: find the energy possessed by an object of mass 10 kg when it is at a height of 6 meter above the ground. Given g is equal to 9.8 meter per second. Mass of the object is equal to 10 kg. Displacement height is equal to 6 meter. Acceleration due to gravity g is equal to 9.8 meter per second. So potential energy, we have the formula. Substituting the values, we get the answer 588 joules. Our next subtopic is transformation of energy. The conversion of energy from one form into another form is called transformation of energy. When energy is converted from one form into another, the total energy always remains the same. Law of conservation of energy. The law of conservation of energy states that energy can only be converted from one form into another. It can neither be created nor destroyed. The total energy before and after the transformation remains the same. Now let us see rate of doing work, power. Power is the rate of doing work. If W is the work done in time t, then power is equal to work done upon time taken. The unit of power is watt W. 1 watt is the power of an agent which does work at the rate of 1 joule per second. 1 watt is equal to 1 joule per second. 1 kilowatt is equal to 1000 watts. Commercial unit of power. The commercial unit of power is kilowatt hour. 1 kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt. So 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour, equal to 1000 watt into 1 hour. 1000 watt into 3600 seconds, which is equal to 1 kilowatt hour is equal to 3.6 multiplied by 10 raised to minus 6 joules. The electrical energy used in homes and industries are expressed in kilowatt hour. The electrical energy used during a month is expressed in units. Here, 1 unit means 1 kilowatt hour. So this was all about our lesson work and energy. Work to be done, energy is the most important thing as it is the ability to work. So work is done when force produces some kind of motion. So learning about them is very important. Thank you, students.